Hello, everyone, and welcome to today's webinar. Today, we're thrilled to have Dia Prembidish with us today to tell us all about using and expanding the NLP Models Hub. Before we get started, I wanted to go over a few housekeeping items. Please note that your console is fully customizable. You can expand or collapse any of the screens. We will be answering the questions, so please use the Q&A panel or chat, either way, and raise your hand if you have a question. Additionally, a copy of this presentation is available in the handout section of the panel. Please keep an eye out for an email within the next couple of days that'll have the recording to this session, a link to the resources, and a quick survey. And so with that, I am glad to turn it over to Dia.
Thank you, Stephanie. Hello, everyone, and welcome to this webinar. Today, we are going to talk about using and expanding the NLP Models Hub. I will start my presentation by giving a general definition of the Models Hub. Then I will talk about the NLP Models Hub, which we have built on top of Spark NLP library. I will then mention how the community can contribute to this NLP Models Hub, and I will finish with a short demo. So, first of all, what is a Models Hub? It is a repository of deep learning models which are pre-trained for a wide variety of tasks and applications. The reason why we should build Models Hub and maintain them is to help improve the sharing of knowledge and of resources and to help advance NLP in all fields. If you are a data scientist or a machine learning engineer, in your day-to-day work you are confronted with training models, fine-tuning them. At least once a day you have to load a model or save it on disk and so on. So in this context, it will be very useful to have a go-to place or a repository where you can find the existing models that you can right away reuse and maybe just fine-tune to solve your particular issue and task instead of building them from scratch. Two approaches exist for this particular purpose at this point, Hugging Face and TensorFlow Hub. And we have recently released our own approach, the NLP Models Hub, which is built on top of the Spark NLP library. So it is part of the Spark NLP ecosystem, and it is supposed to be a registry of pre-trained Spark NLP models and pipelines. So all the models that we train and all the pipelines that we build will be accessible on this NLP Models Hub. It also contains Spark NLP compatible embeddings that are ready to use in any Spark NLP based pipeline. So what differentiates this approach from the two other existing ones, Hugging Face and TensorFlow Hub, is the industry focus. So our purpose is to have models which are ready to deploy and use in production environments. So not just latest research type of models or experiments, but production-ready models which can be right away reused in a production environment. So we have two types of resources currently, general purpose models and pipelines, and also healthcare-based models. So currently, the Models Hub, the NLP Models Hub, lists over 1,200 models and pipelines with NLP resources for over 200 languages. And it offers two main features: model discovery, which can be done through faceted search or through keyword-based search, and also model upload. So for each model, right away on the Models Hub main entry point, main web page, you can see a short description of each one of the models, the title, the publication date, the task for which it was trained, the language it supports, and also the compatibility. So the edition of Spark NLP for which it was trained and tested. Also for the models that Jon Snow Labs develops and maintains, we have the supported tags. So among all the models which will be present on the Models Hub, you can right away identify the ones which are supported, improved, maintained by Jon Snow Labs. So they will have this supported tag. For each one of the models that we publish on the Models Hub, we have description pages which contain the title of the model, a short description of the purpose for which the model was built, a couple of tags for discoverability, a list of predicted entities if we are talking about NER models, but also links for live demos. We are trying to build Streamlit apps for illustrating the use of the supported models that we publish, and also to build collab notebooks which will illustrate to the users how to use the model, and they will allow the user to test the model on their own data. And we also have download links. Apart from those, we try to put together code snippets for Python, Scala, and NLU, and also results. So the user will be able to see how to use the model, how to call the model on some particular data set, and the results that they will get by doing so. Also, model metadata is available on the model description page, such as the compatibility, license, input and output labels for pipeline definition. Also, all the dependencies, such as, for instance, dependencies on certain embeddings. We also have the data source, a link to the data source that was used for training the model, and benchmarking results that we have obtained for each one of the models. Two types of models will be available on the NLP Models Hub. First, we will have the Johnson Lab supported models, which are built by Johnson Lab's team. They are regularly updated, and we try to maintain compatibility with newer versions of Spark NLP. So very often we are revisiting those models, try to improve them if possible, and of course we offer support for our customers who use those models. Then we have the community models, which are contributed by members of the Spark NLP community. Those are automatically tested on upload from a functional point of view, but also from a security point of view. And also their descriptions are manually verified by Spark NLP admins before publishing those on the Spark NLP website and on the NLP Models Hub. We give attributions to the people who create those models, and of course their name will appear both on the Spark NLP GitHub repo and on the Models Hub. So there are two ways of uploading a model on the NLP Models Hub: via the API and also via an upload form, which is readily available on our website. The upload of your NLP model on the Models Hub via the web form is a 4-step process. First, you have to log in using your GitHub account credentials, then you have to upload your model archive. We will parse that archive and it automatically extract some metadata about your model, but you will still have to give additional information, describe your model, and give some usage examples. Then you will just press upload, the upload button, and we will take it from there. So what happens next is the following. The user comes and uploads a model via the API or via the web form from the NLP Models Hub website, and then the model is uploaded to the Models Hub server. Some automatic testing will happen there, and in case the tests fail, the model is rejected and the notification is sent to the user who contributed or who uploaded the model. Otherwise, if all the checkings are cleared, a PR is created for the model description for the Spark NLP GitHub repo. Then a Spark NLP admin will have to check that PR and approve it in case the description is okay. When the admin approves the PR, the model is published on the NLP Models Hub. The model description is published on the Models Hub, and the Models Hub server is notified that this PR was accepted. In that case, the model is uploaded to S3 to the community.johnsonlabs.com bucket. Okay, and the model will be served from AWS. In case the PR is rejected or not approved by the Spark NLP admin, the user will be notified of the rejection of the model, and he can try to upload it again. Okay, now let's go to the demo. The Models Hub is part of the nlp.johnsonlabs.com website, and you can access it by navigating on the models menu item on the NLP website. So here you can see the entry point of the NLP Models Hub. Right away, the list of available models, a very long list. Some of them have the supported tag, meaning that Johnson Lab team is the one who created those models, and they are currently maintained and supported by our team. There are also unsupported models which have been contributed by the community or which have been imported from other sources. Three different filters are available for users to help them find the models and pipelines which they are interested in. So first is referring to the task which we want to solve. Here we have all the tasks supported by Spark NLP, such as name entity recognition, test classification, and so on. Then we have all languages currently supported, over 200 languages, and also all the versions of Spark NLP which we have so far. Okay, let's say that we are interested in name entity recognition models for English for all Spark NLP versions. Okay, so by clicking on Go, I get all the models which correspond to this particular selection. Let's now click on the first result. Okay, by clicking on the model's name, I get redirected to the model description page. Here I see the title of the model, detect PHI for de-identification. I see the text which the user has attached to this particular model. Then I see a description of the model, which will actually explain the purpose for which this particular model was created, and also information about the embeddings which were used for training this model. Then I have the list of predicted entities. So using this NER model, we can identify information such as age, city, date, doctor, hospital, medical record, organization, and so on. So PHI information. Then we have links to live demo and collab notebooks. So if I click on this button, we will be redirected to the Streamlit app built for illustrating how this particular model works. Okay, so we have a description of the app. So the purpose of the model is to automatically identify demographic information in clinical documents using Spark NLP pre-trained models. So here we have a list of documents or sample text that we can choose from, and in the main part of the screen we will see the results we obtain by applying this particular model for predicting for extracting information from the selected text, right? So here we see that the model has identified age, date, doctor name information, date, the hospital, and so on. So all those entities can be used then downstream by the de-identification pipeline to either generalize them, hash them, obfuscate them, mask them, and so on, according to the strategy. Okay, so right away the user can see how this information, how the model can be used, for what is the purpose, what is the business idea behind the model. Okay, then we also have a link to the collab notebook. Okay, so by clicking there we open the collab notebook, and this shows exactly how to set up your environment. Then how to create the pipeline for running the model, right? So you have the document assembler, the sentence detector, tokenizer, word embeddings, and then the clinical NER model and NER converter, and all of those are put together in a pipeline that we fit on an empty data frame, and then we apply to a given text. Here the text is customizable, so the user can change this text and see how the model perform on a custom text. Okay, and this is an example of output. Okay, so they extracted sensitive information, the chunk, and the label which was associated to that particular chunk. Okay, then we have a download link that you can use to download the model. For the open source models, they can be directly downloaded from here. For the proprietary models, for Spark NLP for healthcare models, you will need to have a license key in order to download the model. Then we have also code snippets, which will show very shortly how to use the model, how to build your pipeline, what are the relevant dependencies, such as dependencies on embeddings, and right away the results that you will obtain by running this pipeline. We have also some meta information about the model name, license information, edition, and input and output labels, okay, together with the language for which it was trained. Then we have the data source that we have used for building this model and some very detailed information about the benchmarking results we have obtained for this. So we have entity level information, F1 score, precision recall, and so on. Going back to the NLP Models Hub, let's now search for a model using keywords. Let's say that we are interested in finding models related to drugs. So I will write drug keyword on the search bar and press the search button. This way I can identify all the models or pipeline which are related to drugs. So that means that any model or pipeline included in the result list will contain the defined keyword either on the description or somewhere inside of the model description page. Okay. Now let's see how a user can upload a model and submit it to the Models Hub. There is this option, upload your model, on the main NLP Models Hub website. When clicking on it, you get redirected to the models upload form. So here you get some basic information about the 4 steps that you need to do. First, you have to log in with your GitHub credentials. Okay. After logging in, you can click on the Browse button and select from your local storage the zip file containing the model that you want to upload. So this zip file is actually formed by the model itself together with the metadata. By clicking on the Upload button, the model is copied to the Models Hub server and some tests start running in the backend. So the purpose of running those tests is to ensure that the submitted model is actually a Spark NLP model, that there is no security issues related to it, and that you can build a correct pipeline using this model that can be run with Spark NLP on top of a text, and that you get relevant results. Okay, so all of that is run in the backend to ensure that all models submitted to the Models Hub are of extremely high quality and that they will be production ready. So those tests are automatic, but then there will also be a manual testing stage later on. Okay, so once the zip file is parsed and the metadata is extracted, we will use the metadata from the uploaded zip file to fill in some of the fields in the upload form, in the model description form, such as, for instance, the input labels, output labels. Those are relevant for building the pipeline. Also the edition, the name of the model, all the other information, all the other fields will have to be filled in by the user manually, or else he will not be able to move to the next step. Let's now fill in the other available fields. For the task field, I will choose text classification. So for the title, I will put emotion detection classifier. For the dependency, I will put TF hub use. For the description, I will add automatically identify joy, surprise, fear, sadness, emotions in tweets. I will then give the list of predicted entities, some very basic information on how to use, a link to the live demo that I have built to showcase the use of the model, a link to a collab notebook I have prepared for users who want to reuse this model, some Python code that will illustrate how to use the model for building a pipeline. Same for the Scala code and for the NLU code. the results that we obtain when running the above code, information about the data set used for training, as well as the benchmarking results. When I finished filling in all of those fields, I can now go on and then submit my model. I will then be redirected to a page which will highlight the results of the current submission. I will have information about the pull request which was automatically created. By clicking on this link, I will see my submission, okay, on the Models Hub, this particular pull, commit, and then this pull request. Okay. Now once Spark NLP admin user will approve my commit, the model will become available on the nlp.johnsonlab.com website. So I have shown you today the NLP Models Hub, a project we have been working on for the last couple of months. Our desire and intention is to make this a reference place for all Spark NLP related resources, models, pipeline, embeddings, and so on. So what differentiates us from the other model hubs already on the market is the fact that we want to ensure the very high quality standards for all the models that we publish on the Model Hub. Okay, so first we will do that by publishing the models that the Johnson Labs team are building and maintaining, so the supported models that we are revisiting periodically and ensuring that they have very high level of accuracy, and we improve if possible. Then we impose very high quality bar for all the community contributions, and we do that by implementing automated testing, which will make sure that the models actually do what they are supposed to do, what the descriptions are saying, that the level of documentation is appropriate so that people will know how to use those models and how to fine-tune them. Then the accuracy metrics that the users have published or have declared are transparent and are correct, and that the training data sets are sufficiently described. So this is all for today. Thank you very much for your participation. And if you have any questions, I'm available either via chat or by email. This is my email address. Thank you so much.
Great. Well, thank you so much. That has been very informative, and I definitely learned a lot. Before everybody runs today, I did want to mention that we do have the upcoming NLP Healthcare Summit that's going to be held on April 6th and 7th. So we're just a month away, and this is going to have 30 sessions and over 5 days of online training available. It's an industry-wide conference focused on applying natural language processing in healthcare. And so during this 2-day event, we've got excellent speakers from Google, Microsoft, Amazon, Cigna, and many more. So we hope you'll join us. I am popping the link for the more information and to register here in the chat box, and we look forward to seeing you there. Thank you so much for your time, and have a wonderful day.